Okay, good morning, everyone. I hope you can hear me. Please confirm if you can.
I can hear you.
Okay. I think it's already time to proceed. So, my name is Michael ADEGOKE. From the DevOps and Infrastructure team, and today I will take you through my presentation today, which is Docker Demystified, unlocking the power of containers. Over the next little while, that's about 15 minutes or so, we'll cover why containers matter, what Docker actually is, the core concepts, there's images and containers, how it works under the hood, Docker architecture, um, how you can practically use it in development and production also. And I'll just include a few like technical details for the engineers in the room. I'll also try to explain things to a high level for the beginners and the non-technical people on the call right now. So let's begin with the problem itself. You've probably heard this complaint a thousand times when maybe with developers or something, when they say, but it works on my own laptop, it works on my machine, it works on my local machine. That phrase captures a fundamental pain point in software delivery, and that is the code that runs on one environment but fails in another. When we copy files manually, when we install packages by hand, or when we rely on slightly different system setups, the deployments will become really fragile. A tiny difference in a library version or a missing dependency, which is really, really common in software engineering and software development. This tiny difference can lead to hours of debugging, and Docker exists to address exactly that. It promises like a way to package applications so they behave the same across development, across testing, across production. So in short, the containerization is about removing environmental surprises, shortcomings, and making your deployments predictable. So what really is Docker? Um, at high level, Docker is a platform that makes it straightforward to create, to deploy, and to run your applications using containers. To bundle your application and everything it needs. That is your libraries, your frameworks, and your configurations into a single portable package. So according to this slide, Docker is a platform designed to make it easier to create, deploy, and run applications by using containers. It bundles everything into a single package also. And that package runs in an isolated environment. And this prevents conflict between applications and ensuring there's a consistent behavior across different machines. So compared to your virtual machines, the containers will share the host kernel. So they are far more lightweight and they can start even much faster. So a simple analogy here is just to think of your Docker images as your shipping containers for software that you can move and then you can run at any time, at any place. So imagine packing your entire application like a small appliance that works the same, whether it's plugged in a house in Lagos or in Kenya or in London. That's basically the entire point of what Docker is. And your core concepts, that's your images and your containers. There are three core concepts when dealing with Docker. And the first is your image, the second is your container, and the third is your registry. You create your image is like a read-only template. You create images from a Docker file, and there's like a list of instructions, like assembling the environment and all. And this image is immutable. Sorry, please confirm if you can still hear me.
Yes, I can hear you.
Okay. And then the second concept is your container. That container is an instance of that image. The image is read only, and the container is read write. So it's created from the image itself. The container is created from the image itself and does all the applicable things you want to do. And if an image is like your blueprint, the container is like the house that you built from it. And then the third is your registry. Registers like places like Docker Hub where the images are stored and shared. And you build an image, you run your container from that image, and then you push that image to a registry where you want to share with people, your other teammates or any other person for them to use maybe in their different pipelines. So when just like a small tip, when you change your code, you rebuild your image. You know, when you want to run the app or that you instantiate a container from that new image. So how Docker works under the hood. So if you're curious about the mechanics, Docker leverages several Linux kernel features to create your lightweight isolation. That's your C groups, your namespaces, your layered images, virtual network bridges. They leverage all these things to limit your resources like your CPU, your memory, and or the namespaces will give like each container its own view of processes like the network and the interface, file systems and all. And your layered image will use like a copy on write approach. So images can build efficiently and be shared across different images. Docker also uses a virtual network bridges so containers can communicate with each other and with the hosts. So together, these pieces let containers to be fast, be compact, and isolated without the overhead of a full virtual machine. So your namespace, your C groups, that's like your process and your resource isolation. You know, layered file systems, that's your fast pools and your efficient storage. And this is your architecture overview for Docker. You know, when you map all these components together, you encounter the Docker client, and that's what you use to issue your different commands. And it sends CLI and API commands also. You have your Docker daemon that runs in the background. It manages images, it manages containers, manages your networks and your volumes also. Then you have your images itself, your Docker images, that the packaged snapshots. The containers are also running instances in those images. You have your Docker desktop, and that is just like a convenience for Mac OS and Windows. It bundles the daemon, your clients, your Docker Compose, and you have your local Kubernetes option too. That's handy for your Docker desktop is handy for local development if you want to work on your desktop and you want to connect to it, just to visually see how your Docker images, your containers are running. You can also check your logs from your Docker desktop. Everything will be visualized. If you don't want to run too many codes on your terminal, your Docker desktop will give you like a proper user interface where you can interact with your images, your containers. You can check your logs. You can check if there's any error or if you want to even check the states, and you can just check all of that from your Docker desktop. If you run into an issue, the Docker desktop will actually show you, like I said, the logs, and you can copy and paste into wherever maybe your Stack Overflow or your in this case your LLMs to figure out what your problem is or where your problem originated from. So why does Docker matter in the real world? For developers, it brings development production parity. What you test locally is what you can run in production. So there are like fewer surprises. For your data scientists, the containers help to create reproducible environments. So the models can be reproduced exactly. And for companies, containers enable your microservices and architectures and seamless integration into orchestration tools like your Kubernetes. And this allows services to be able to scale independently and roll out updates with confidence. So in short, your containers will speed up your delivery. It will improve the reliability and make scaling more manageable. So just take note, this is about reducing risk and speeding delivery cycles. It requires investment in operational practices, and this is something that is important for management. So Docker in action is just a practical end-to-end workflow, so you can apply immediately. If you just want to test in a simple manner, you define with your Docker file, you create a Docker file, and that's like a text file containing the instructions on how you want to build your Docker images. You write simple text files inside, you specify the base image, it copies requires files, it installs your dependencies and declares the process that it needs to run. The other step is to build the image. You use your Docker build command, and that produces a portable image that you can test locally. And then you run your container with the command docker run. That's mapping your ports, your volumes when needed. And the fourth step, that's to share and distribute. That's by pushing your image to your Docker Hub or your private registry if you want. So teammates or CI systems can pull and run the same image. So this workflow just creates reproducibility and across development and your deployments also. So Docker itself still comes with challenges. There's no system that is perfect. I know softwares, everything is still, there's always still room for improvement. As efficient and helpful it is, there will always be like some small challenges that you experience. So your containers are not like silver bullets. They can address environment reproducibility, but they don't magically just fix your architectural or integration issues. You still need to configure external services like your databases, your cloud resources. You need to configure all of this correctly. So one of the tips is just to be mindful of your image size. Prefer minimal based images to and multi-stage builds to avoid shipping build tools in production images or to pin base image versions for reproducible builds. Scan your images for vulnerabilities. When things go wrong, start by checking your container logs. And I've mentioned that already. You can check with some Docker commands if you're on your terminal. If you've installed your Docker desktop, you can also visually check your logs because it provide logs for you when things go wrong, and you can just go through them if you can read them. If you're just starting off and you don't really understand, you can check Stack Overflow, you can check your LLM, your generative AI to break down the logs for you and explain where the vulnerability or the error came from. So like I said, when things go wrong, just start by checking your container logs, inspect your image layers and find where maybe a dependency or a configuration slipped. You can use your Docker log command. You can check your containers with your Docker PS, and you can also run Docker inspect for those that want to interact via their terminals. Master your troubleshooting. This is one of the. This is just a general tip, not just for the DevOps engineers, just for everyone that's going to be everyone technical, honestly, because there'll always be errors. Even if you have a system that runs 99% of the time, that 1% can happen maybe once a year, but whenever it happens, you have to be ready for that. When there's an error, when things go wrong, um, you should know how to master troubleshooting. You should know how to understand the kind of errors you're seeing and how to pinpoint how to solve something like that. So the future of Docker and containerization. Looking ahead, your container orchestration continues to be dominated by Kubernetes. which helps to manage like your fleet of containers with rolling updates, health checks, and horizontal scaling. So this ecosystem is expanding. Docker Compose still remains useful, though, for your multi-container development and stacks, while alternatives like you have your Podman, your Builder shows like there are more tooling options. Each one has its own trade-offs. So the point is, containerization is now essential to modern DevOps, CI/CD, and cloud native strategies. So if you want to stay current as an engineer or a team, understanding containers is extremely crucial. Don't just don't just practicalizing things is really good. That's one of the best ways to learn when you make your mistakes, when you see different kinds of errors. Repetition will help build your memory and all. But to really demystify what this is, you need to just understand a lot of things from the scratch. You need to understand your just differences between like your Docker, your containerization, your virtual machines. You need to understand things from the roots. So if there's a major problem in the future, it's not just you are not just going to look at it from a point where, or from a perspective where all you have is like maybe a practical question and answer reply to things, or it's just okay, this is a particular error. This particular kind of error requires this kind of answer. In some cases, just a small issue can just be a small symptom of a larger problem. So approaching containerization, approaching Docker, approaching Kubernetes is not something you should just do from a project or practical point of view. I think you should still have a fundamental understanding of what you are dealing with, and this will just give you a mental image of what you're working with, especially from as a system engineer, system designer. There are going to be cases, especially when containerization even becomes way bigger than it is now, where something can fail, and you have to just really figure things out from a fundamental perspective, and building the foundation where you just demystify things beyond the commands, beyond the codes they are going to be writing, to a point where you understand the actual flow, the actual workflow. You will be able to embrace the journey of experimenting with Docker itself. So that comes to the end of this presentation. If anyone has a question for me, please, you can signify. Does anyone have a question? If you don't, I'll proceed to ask my own questions. Okay. So my first question is, what major problem does Docker help solve in software development? So this question, okay, Emeka Friday, your hand is up.
Okay. Yeah. Good morning, everyone.
Good morning.
What I understand from what you have been saying, Docker helps to make the developer achieve the same behavior, like the project will behave uh, uniformly in any environment. Maybe like rather than uploading your file manually one after the other, you can when you use Docker, it helps to achieve uniform behavior for your project across all environments.
Yes, so your the performance is similar to the host for CPU and bouncer. So the one of the benefits of the itself is consistency, and like like what you are trying to say, reproducibility. You can reproduce on different environments.
Yeah.
Okay, so my question, like I said, what major problem does Docker help to solve in software development? Can anyone can anyone answer? Yeah, I'll have to ask. Um, John Adibajo, can you hear me?
Yes, I can. Yes, I can.
Yes, good morning.
Good morning.
Can you please answer? Can you please
Morning.
answer the question?
From what you said, yeah, I think the first thing you mentioned was the fact that it works on my machine, it doesn't work on another machine, which simply means that various machines have different operating version, different dependencies. So Docker helps to package all that so that you can have the code, the runtime, and the dependency, and we can and put it into a container, and which ensure that we can make that run on uh, every other every other servers. So packing all those things together. That, for example, you mentioned that things might be working on my machine, doesn't work on other machine. So Docker helps to solve that issue, whereby you can put the code, the runtime, all the dependencies all together into a container, ensuring that the app runs everywhere. And also we have the fact that, for example, when you have maybe difficult inconsistency in deployment. So probably it helps to package everything in one so that the thing, and it also helps in scaling also to, it helps to scale your environment also. So I think those are what I understand that that's one of the things that Docker helps to solve in the software development also to making it easy.
Yes, thank you very much, John. Yes, so Docker helps to solve inconsistent environments. Different computers have different setups, like John said, different operating system versions, different libraries, and different configurations. So an app that works perfectly on my laptop may fail on someone else's machine or even on the production server. And he, just to show that he was really listening, he mentioned the whole "it works on my machine" problem, the biggest frustration in software development, where developers will test code on their system and everything runs smoothly. When they ship to another environment, things break. You know, package might be missing, dependency might be outdated, the OS might be different. So Docker can just solve this by, the Docker packages and everything the app needs, the codes, the libraries, the system tools. It packages everything into a single container image. And that container behaves exactly the same, whether it runs on your laptop or a server or the cloud. So just think of a container as a self-contained lunchbox. So no matter where you take it, home, office, or school, the food inside will remain the same. Docker does the same for software. The environment stays the same everywhere. So thank you very much, John, for that question. Maybe if we have time for a second one. What do we call the place where Docker images are stored and shared? I think I mentioned this like in the beginning of the presentation. Can anyone answer this? What do you call the place where the Docker images are stored and shared? Manuel Kingsley, are you on the call? Good morning. Kingsley Emmanuel. Okay.
Sorry, can I
Anita
take that
Okile.
question?
Oh yeah, you can. You can if you want to. Yeah.
So I think for me, you can store Docker images on your local machine, or you can probably store it on Docker Hub also, which you can push the images to Docker Hub, and you can pull them back also. So
Yes, that is your registry. So your registry is simply a storage location for your Docker images. So it's like you can think of it as a warehouse where you upload your images and download them wherever you need. So it stores your container images. It allows others, as like your team members or the servers, to download them, and it keeps versioned images, stored public and private, supports public and private access to. So this matters because if you build an image on your laptop, how does your team or your servers in the cloud get it? They pull it from that registry, from that Docker registry. So that registry is extremely important. It's a beautiful storage location, a beautiful warehouse, and you have different types. You have your Docker Hub, you have your GitLab registry, you have your GitHub Container Registry, AWS ECR, Google ECR. So your registry is like for the non-technical audience, it's like your Google Drive, but for Docker images. You upload your image there once, and anyone who has access can download and run it. So thank you very much, everyone, for listening, and thank you very much for the questions answered. That comes to the end of my presentation.
All right. Thank you, everyone, for joining. Please,